Welcome back, everyone. It's time for Notes 2-1 and 2-2. We're going to do both these in one fell swoop. You're not going to do as much writing in the notes in terms of every property, but we will get most of it filled in and then have a few examples. Especially for 2-1, we're going to move pretty quickly here. So equation, you can see the vocabulary here, is a statement that two expressions are equal. The solution of an equation, obviously, right, it's the answer. It's the value of the variable that makes the equation true. The properties of equality, each of the four operations has its own property of equality, and they did give you room in your notes to write all of them down, but I think doing a quick overview is probably sufficient. They all really say the same thing. Whatever you do to one side of the equation, you must also do to the other side of the equation so the two sides stay in balance. So if you want to add 3 on one side, you got to add 3 on the other side. Think of it like babysitting twins. Whatever you do for one kid, you're going to have to do for the other kid. One-step equations, you should be a pro at these already. So just one quick example of each kind here. X minus 7 equals 4. Our goal is to get the variable all by itself. And so we're going to take that 7 and add it to both sides. Okay. And these 7's go away, and we're left with x equals positive 3. 3 minus 7 equals negative 4, so I know it's right. A plus 16 equals positive 3. I want to get this 16 to become 0, so I'm going to subtract 16 from each side. I often find it easier to write subtraction horizontally. These 16's disappear, and therefore A equals 3 minus 16, or 3 plus negative 16, which is negative 13. Quick check, negative 13 plus 16 will equal positive 3. On to a multiplication equation. 6 times m equals negative 72. We want to get the m all by itself, so we're going to divide both sides by 6. That gives us 1m instead of 6 m's, and that means that m is going to equal negative 12. It's good to know those 12's times tables. 6 times negative 12 is negative 72, so I know I'm correct. On the division equation, we're always going to take what's in the denominator, and we're going to multiply both sides by that. Notice I'm writing that negative 9 up in the numerator, and that's because I want to get an equivalent of 1. I call it a fancy form of 1, a foo. We'll talk more about that in class. And we get k equals negative times negative is positive 63. Quick check, 63 divided by negative 9 is going to equal negative 7. Okay. We'll do some matho on when you come back to class on this. So you get a little bit more one-step equation practice, but you should be a pro at these. We'll move right on to two-step equations. 2-2. First thing I want to talk about here is something that doesn't need to go in your notes. It's just, I call it the equation machine. I want you to think about what's happening in an equation. When I write the equation, 7x plus 6 equals negative 43, let's think about what's happening to the x here. So the first thing that happens to the x is that it's multiplied by 7. And then after that, 6 gets added to it, and that turns out to equal negative 43. When I solve an equation solving is really a process of working backwards. So I'm going to take that process, and I'm just going to do everything in reverse. So that means if the last thing that happened in my equation was adding 6, then the first thing that's going to happen now when I undo it is that I do the opposite, and I subtract 6. And then after that, right, I'm going to undo the multiplication by 7, and I'm going to divide by 7, and that'll give me the value for my variable. This is good to keep in mind as we do more complex equations in the near future. Okay, let's get this bar to go away. I do request strongly that you use what I call the standard format for showing your work, right? You write each step on a new line. We're always going to start by adding or subtracting to get rid of the number not attached to the variable. You can write these steps down in the space below where it says solving two-step equations there in your notes on page 23. Okay. So in this case, if I add and subtract, I'm going to get my magic eraser here. I'm going to get, right, after I subtract 5 from each side, I'm going to get y over 7 equals negative 14. If you like to show the minus 5 on below, that's fine. You can absolutely positively do that, okay, but you don't have to. Then you're always going to do the multiplication or division to get the variable all alone. So in this case, we'd multiply both sides by 7, and we would get negative 98. It is always a good idea to check your solution. I don't generally require that you write the check down. It's a good time to practice using your calculator, though, and make sure that it actually works. When you check your answer, remember you put it back in and you work your way forwards through the problem, right? Just like in the machine. So we plug in negative 98, we divide it by 7, then add 5. And yep, sure enough, it equals negative 9. So let's do an example here. This is probably the only example we'll do for this two-step version, I think, except maybe a fraction one after this. Okay. So we're going to start by adding or subtracting the number that's not attached to the variable. That's the 12. Okay. You can write it if you like. Don't have to, but you do have to write this line. Negative 8x equals negative 36 plus 12 is negative 24. So I want to see the problem written down. I want to see the second line of the equation written down. And then if you like, you can show that you're going to divide both sides by negative 8, or you can just do that part in your head, and you end up with x equals positive 3. So two-step equation, 3 binder paper lines to show me your work, and then quickly, at the very least in your head, you do a quick check. Negative 8 times 3 is negative 24, minus 12 equals negative 36, and sure enough, that's true. Okay. What if the variable's negative? This always trips people up a little bit because we know we want to get rid of that 8, but when we get rid of the 8 by subtracting it from both sides, right, now we have 12 equals, and then we've got this minus n hanging out here. Remember, anytime you have subtraction, always a good idea to add the opposite, zip zap it. And so now you can see that what it's equal to is actually negative n. Well, I can't finish off a problem with a variable that's negative, so what I can do to that is, well, I need it to be positive n. So I can divide both sides by negative 1. I could actually multiply both sides by negative 1 also. It would be the same thing. So instead of positive 12 equals negative n, I get n equals negative 12. And then check it, right, in your head or calculator or on paper. 8 minus negative 12 is supposed to equal positive 20. Zip zap, adding the opposite, and sure enough, it works. And so zip zapping is often the key to making your life with negatives easier. Okay. Fractions. This is the last little bit here. Your choice is to either deal with them as is, get your common denominators, slog your way through it. It all will work out. It's all right. Or you can multiply both sides by the least common denominator. The nice thing about this method is that it turns all the numbers into integers. It essentially clears out the fractions. You can use either method. I usually choose based on how challenging the problem is. Go ahead and write this example down. Right, you've got all this space below the two-step equations box there, and you should have already put in the previous two equations into the box, so now you can put this below. Okay. So on this one, I'm going to show you the method of clearing out the fractions. If you want to try it both ways, you certainly can in your notes. So I'm looking for the least common multiple of 3, 4, and 12. And that's going to be 12. And I'm going to multiply both sides of the equation by this. Okay? Remember, whatever I do to one side of the equation, I got to do to the other side. And then I'm going to distribute it. Right? Math's getting complicated. Hang in there. Right? So I have 12 times 2/3. Well, 12 times 2/3, and put that down here, 12 times 2/3, that's 8. So I have 8 r's plus 3/4 of 12. Well, 1/4 of 12 is 3, so 3 of those is going to be 9. Plus 9 equals, well, this one's nice, 7 over 12 times 12 over 1 equals 7. Right? And now, voila, no more fractions. Right? How nice is that? Now I can go ahead and just solve. Right? So I'm going to take 9 away from each side, and I get 8 r's left over on the left side equal to 7 plus negative 9 is negative 2. And so r equals negative 2 over 8. Always finish by simplifying your fraction. So r equals negative 1/4. Okay. Not going to take the time right now in the video to check the answer. If you don't believe me that it's right, you can go ahead and do it on your calculator. It does work, I promise.